So I'm just going to do a little review on displacement from velocity. I guess not really review. Um, and what we're going to, whoa, that was weird. And what we're going to do is we're given a graph like this, something like this, right? And we got to figure out what the displacement is for that graph. And this should look somewhat familiar because before we had this, but we just didn't have this angled line going through it, right? And that angled line, remember, means that this thing is accelerating from 2 seconds to 5 seconds. A straight line on the velocity time graph means it's accelerating. It's a negative acceleration. Um, so what we're going to do is figure out the area above and below this graph. So if we figure out the area, I'm just kind of show you where we're going. We figure out the area above right here, right? And we figure out the area below down here. What we're really looking for in the end is it's going to be the area of this thing minus the area of that thing. And that's what's going to be our overall displacement. So what we got to do is really just figure out surface area of stuff. So pretty much just a basic math problem. So we're going to split this up into different shapes. We're going to figure out what's the area of this square. That's going to be base times height. And then we're going to figure out what's the area of this triangle. And then the area of this triangle. And then the area of this last triangle. So we got that. There's four things we got to do here. Okay, and that's what I've got written down here. So we figure out the area, so velocity times time, which is base times height. And then for the area of a triangle, the only difference is it's going to be 1/2, right? The area of a triangle is just 1/2 of a square because this would be the square, but we are only taking half of it. So, okay. And then do the same for the bottom. You can kind of see I've done the same thing there. But you notice that I get a negative displacement there and a negative displacement there. So now to calculate the total displacement, all we do is add them all together. We take the sum. So we go 20, that was the first area, plus 10, the first triangle there, minus 2.5, and plus negative is the same as minus, right? And then minus 15, so we get positive 12.5 meters would be our final displacement there. And we learned all that just from looking at the graph.